This lecture is on solving linear programming problems in the first quadrant by Dr. Archie Earl. These are the steps involved in solving linear programming problems in the first quadrant. Step number 1, you have to find the solution to the system in the first quadrant. And this was done in the previous lecture concerning linear programming. So you can refer to that lecture for step 1. Step 2, you have to test the corner points or the vertex points in the given equation, which is the objective function. They will give you an equation along with the inequalities. And after you find the solution to the system of inequalities, then you have to look at the corner points or the vertices of the graph. And you have to plug those numbers at the corners into the objective function to see if the numbers will maximize or in some cases minimize the objective function. So step number 3, the solution is the point that maximizes or minimizes the equation as requested. So sometimes they will request you to maximize the objective function, which is the equation that you have in the problem, or they will ask you to minimize that value. So you have to respond accordingly. Here's an example. For this example, we want to find the maximum and minimum of the objective function. We want both in this case. We want both the maximum and the minimum. In a lot of problems, they just ask you for one or the other. But in this problem, we're asking for both. And here's the objective function, which is the equation. That's the only equation we have up here. The rest are inequalities. So the equation is z equals 5x plus 2y. So you have to get the vertices or the corners, and you have to plug the numbers into this equation here to see which one or which numbers for x and y will give you the maximum value for z, and which numbers for x and y will give you the minimum values. And you're only testing the vertices or the corners of the final graph. These are the constraints or the inequalities. They are called constraints when you work with linear programming. First equation is 10x minus 2y is greater than or equal to negative 8. Now we have really essentially done this equation already. We did it in one of the previous tapes. 10x minus 2y we had greater than, but it would be basically the same as what we have there. You see, we had 10x minus 2y is greater than negative 8. So it would be essentially the same, but it would be a solid line. That's the only difference. So this line here would be solid. So we've already done this part. And of course, you just solve it for y, plug in a couple of numbers, graph the two numbers and draw the line, and then shade the region. And we shaded the region for that. Okay, the next inequality is 4x plus 3y is less than or equal to 12. And this one we have already done. We did it in the previous lecture. We solved the equation for y, and then we found a couple of points, and we had 0, 4, 3, 0, and we graphed that inequality in the same xy plane. So we've already done that, and we got this. So this is the intersection of those two. Now, the third one we haven't done. The third one is x plus 2y is less than or equal to 6. So we have to do this one and graph it in the same xy plane that we graphed the other two in. And then we have to get the intersection of all three. But these two we don't have to worry about. These two just assure that we're in the first quadrant. If x is greater than or equal to 0, that means we're in the first quadrant essentially. We have or equal to, so we could be on the x or y axis, but essentially we're in the first quadrant. So we really don't have to graph these two. These two just assure that we're in the first quadrant. Y is greater than or equal to 0. That would be in the first quadrant. The x-axis are in the first quadrant. So that's what these two assure. So we don't have to graph these last two. We only have to graph these three and get their intersection only in the first quadrant. All right, so for these two graphs, we can erase this part back here. You see, this is not in the first quadrant. So we can erase that. You see, this part down here is not in the first quadrant. When you're doing linear programming, really, most of the problems are in the first quadrant. So this is what we have so far. Only what's in the first quadrant for the intersection of those two. Linear programming. So we just need to do the last equation and graph that. So this is the last equation. X plus 2y is less than or equal to 6. So we just have to solve that for y. We have x plus 2y less than or equal to 6. We subtract x from both sides. We get 2y is less than or equal to negative x plus 6. We divide both sides by a 2. Do we have to reverse the inequality sign when we divide both sides by 2? If you said no, you're correct, because we're dividing both sides by a positive number. You only have to reverse the inequality sign if you're dividing both sides by a negative number. So we just get y equals negative 1/2 x plus 3. Y equals negative 1/2 x plus 3. Not equals, but it's less than or equal to. Okay. Y is less than or equal to negative 1/2 plus 3. And then we just choose any two numbers for x, and we find y. And I chose 0 and 2 for x. And if x equals 0, if you substitute a 0 in here for x, you get y equals 3. If you substitute a 2 for x, you get y equals 2. So these are my 2 points. So now I just need to graph these 2 points and draw my final intersection. So I have 0, 0, 3. So I don't go any right or left. I just go up 1, 2, 3. So that would be this point right here. And for my next point, the next point is 2, 2. So I go 2 to the right, and I go up 2. So that would put me there. And then I draw my line. And then I know it's solid because I have or equal to. My line is solid because I have or equal to. So this is my line here. And once again, It is solid because I have or equal to. And now it says less than or equal to. Less than or equal to, that means I shade below the line. Less than means below. So I'm going to shade below the line. Now notice how I'm shading. I want what I'm shading now to intersect with what I already have. So I don't have to shade over here, you see, because that's not already in the intersection. What I'm shading now has to intersect with what I already have. So I can't shade any of this over there. I can't shade any of this below here because I don't already have it. I can't shade right in between there because I don't already have it. But I can only shade below this line right here. That's the only place I can shade. It's right there below that line. So that would be my region. And now I have to write down the corners or the vertices of this region. And I have to check them out in the objective function to see which one will maximize it, which one will minimize it. So 0, 0, you usually don't really have to worry about that because usually that's not a real player in deciding the maximum and the minimum. You can try it in there, but usually you get 0 when you put those two in there. So really, we need to check out this point here, and this point here. See, those are the points that we need to check out. Once again, we need to check this point, and that point. They are the vertices or the corners of the solution. So what we have here is 0, 1, 2, 3. So that's one of the points that we have to check out. 0, 3. X equals 0, y equals 3. That's this point here. 1, 2, 3. 0, 3. Okay, this point is 1, 2, 1, 2. So we have to check out the point 2, 2. See if that's a minimum, see if it's a maximum. And last but not least, we have to check out this point here. We have to check out this point here, which is 1, 2, 3, 0. 3, 0. So those are the 3 points that we have to plug into the objective function to see if it gives us a maximum or a minimum. All right, so that's what I've done here. I've plugged in the 3 points into the objective function to see which one will give me a maximum, which one will give me a minimum. I plugged in 0, 3. That means that I plug in a 0 for the x and a 3 for the y. So I got z equals 5 times 0 plus 2 times 3, which gave me 6. Next, I plug in 2, 2. X equals 2, y equals 2, z equals 5 times 2 plus 2 times 2, which would give me 14. Next, I have z equals 3, 0. Z equals 5 times 3 plus 2 times 0, and that would give me 15. So as you can see here, the minimum is 0, 3. You see, x equals 0, x equals 3. The maximum is 3, 0. So for the answer, you would have 3, 0 for the maximum, and you will have 0, 3. X equals 0, y equals 3 for the minimum. So that would be your answer to the problem. And once again, you can express your answer really in either of these 2 ways. Usually we state it as x equals 3, y equals 0. But occasionally you might see just a point representing the solution. All right, for homework, this is what you want to do. Page 409, you want to do number 25 and number 27 on page 409, or per your instructor. If your instructor gave you other problems to do related to this topic, then you want to do those problems. If you're just doing this for self-enrichment, you can get any algebra textbook, look in there, and get some of these types of problems and work them out. Have a great day. Bye now.